layer, what it is, what you use it for, why you should care, and then we're going to go over an interactive notebook. We'll have a link up there, and one of the two will go through it with you. So what is natural language processing? I have my slides up here. Let's see. So natural language processing is trying to turn what we do very easily, which is natural language, the spoken language, and get computers to understand what that is. So let's say a chair. How do we know what a chair is other than a combination of 5 letters? And how do we get a computer to contextualize it, understand it? I was going to do the Coco the gorilla type thing, teaching an animal what these things were. I learned yesterday that Coco the gorilla is a lie. Oh, so sad. The second thing is the automated manipulation of spoken language. How do we get these computers to, say, generate text for us or pull data from it? Next slide. In a more practical sense, so let's say you're a big business or you are an aspiring research scientist, there are many of ways that we can leverage natural language processing, mainly because language is so important to our lives, what we do, how we interact with people, from recommender systems to sentiment analysis, all the way to very basic things like spell check, autocomplete. These are things that we use natural language processing for in order to do things on the internet. Next slide. So first, I'd like to say that if you're interested in this type of stuff, it's not necessarily solely part of AI. There's a whole field of linguistics that natural language processing is a part of. Computational linguistics is a very cool field. Oh, hi, Connie. And these are very interesting things. Please look into it. Linguistics classes are cool, even though I have yet to take many. So why should you be interested as a student who, first of all, may or may not know if you're interested in machine learning, AI, if you, like me, have trouble saying words and writing coherent sentences. The biggest thing is you speak a natural language every day. We've gone over this a lot. You understand the difference between a bean and a can. The second thing is there's lots of applications. I didn't put it on here, but machine learning is a very special field, as in it's fairly complicated. But because it's so popular and so many resources have been made that make it easy to get started and continue, much of like, what are we doing here? Secondly, compared to other types of machine learning research, there is a lot of data. Everything that has ever been written, documented, and put online is a resource that you can tap, whether it be Twitter, Reddit, your library, Wikipedia, that type of thing. Lastly, if you want to go into this from an academic standpoint, it is a very bustling research field. I had a bunch of the conferences, but I don't think I want to say all of them because there are too many. But there are plenty of conferences that are going out throughout the year that it is feasible for students to contribute and get a paper published. Other things, I put it here. Lots of research to learn from, lots of guides, YouTube videos, that type of thing, that is well supported. Whereas with other types of computing, you have a lot of problems having to make things from scratch. There are lots of packages in Python, say NLTK and scikit-learn, that make it very easy to get started. I also think that sometimes, especially because there's language involved, when you get bad outputs, it's quite funny. And I'll pass it off to Jackie.
Hi, everyone. So now we're going to be doing the interactive notebook part of this. So please go to this link, acmurl.com/NLP interactive 1. This is for Twitch. Hello to our Twitch fans. So is everyone at the notebook, or do we need any more time for that? Okay, so first thing you want to do is make a copy of this notebook. So go to File, and then you can save a copy in Drive or place of your choice. And if you still need to check in for this event, you can click this link right here with a check-in code, and you can make an account with ACM if you haven't done that already. This link will be valid until 7. So the first thing we're going to be doing is setting up. So we're going to download the data set, and I would recommend downloading it right with this link right here, this Google Drive link, just so it'll be named the same thing that ours is. So you can copy and paste this into another tab. Which link? Yes, okay. Can you see that okay? Huh? I would not recommend the Kaggle link. I would recommend downloading from the Google Drive link right here that my cursor's at, just so it may be named the same thing. Is everyone good to move on? Do we have any questions? Okay, sounds good. So I would check right here with your files. So just open this Twitter sentiment folder, and if you don't have a test.csv and a train.csv, does anyone have the issue where their folder is just empty?
Wait, do we drive the zip file into that?
I don't think you will be dragging anything. It should just be there. Huh? Chris, can you help them? Sorry, I can't hear. Where's my mask? Where's my mask? Does anyone need help with just the folder stuff? Oh. Hi.
Is this the right link that I've been putting in?
Interactive.
Yeah, my phone was
Maybe, let me go back to the link and see if it's still valid. You're gonna need it should be URL, not UCSD.
okay, ACM URL.
Yeah. Oh, do you need help?
Oh, yeah.
What's the issue?
Oh, never mind.
Oh yeah, so that thing, so I'll go over that in a second. I just want to make sure like most people's are empty. Is anyone's Twitter sentiment folder empty, like on the left? Okay, you have it. Is yours empty?
I edited like this. I added Twitter sentiment.
Okay, but I was like talking about right here. It looks like it's good. Okay. Okay, so for people who have the issue of like in their Twitter sentiment folder, there's no like test or train.csv, which I saw some people have that issue. I would recommend clicking this right here and uploading it manually. So I would go to the unzipped like Twitter sentiment file, or folder, and then I would just click both of these and open these. And when you do that, it probably will end up here. So you can change the code to, just do content/train.csv if you have that issue. But if you don't have the issue, you can just like do /Twitter hyphen sentiment /train.csv. Hello. Oh. Is anyone else having any issues with pressing play on this first thing? Okay, so for right now, I would press play on the first 3 cells. So press play on that, and then press play on import libraries. And then finally, press play on load datasets with pandas. So if any of those have errors, please raise your hand and we can come help you with that. Vincent. Hello.
I'm getting this error for a load data set with pandas.
Okay. So I would go here, and you see how it says /content? I would do after the content, do /, and then Twitter hyphen sentiment, and then do the same thing for the other one, and it should work. Okay, yeah. Is anyone else having that issue with the files or loading pandas? Hello. Okay, yeah, so can you go on the left and open your Twitter sentiment folder?
Oh, yeah.
Okay, so you need to go to content and then do /Twitter sentiment /train CSV.
Okay. Yeah, that makes sense.
Okay, yeah, do it for both of them, and let me know if you have any other issues. Is everyone good on the Twitch chat? Do we have any questions there? Okay, sounds good. So is anyone having any other issues with load data sets with pandas? Oh, wait, someone has a question over there. Chris, can you help them? Okay, sounds good. So we're going to be moving on into exploration of the data set. Oh, please hold. Okay, so we're going to be ignoring the test data for now, and we're going to be exploring the train CSV. So Colab has this great feature where you can explore the tables, but we'll be using pandas today. So does anyone know what snooping bias is? Did you hear that? I'm sorry, can you say that a little bit louder?
Like you want to ignore that.
Yeah, it's pretty similar to that. It's basically ignoring the test data, so you make sure that you're not like making your model biased on that. So we have this table right here, and it shows it's just a table of all the tweets. So each tweet has an ID, which is like this is tweet number 1, tweet number 2, and then it has a label. So we're going to be using a hate speech data set today. So some tweets contain hate speech and some tweets do not contain hate speech. So 0 would mean this tweet does not contain hate speech, while 1 over here means that it does contain hate speech. And so this is the tweets. So they have 3 categories: the ID, label, and tweet. And then the tweets are labeled 1 to 0, like I just said. And then the tweets have like @user, just like to preserve privacy, because this is like real tweets. So does anyone know why we use 0s and 1s to denote non-hate speech and hate speech and not other numbers? Yeah, that's pretty close, yeah.
It doesn't matter what number to use.
So it doesn't matter what numbers we use, but we just want to make sure that we have two different things that denote. So we honestly don't even have to use 0 and 1, but it just makes it simpler that way because usually you start counting at 0 in computing. So let's generate some word clouds for the common words in hate speech tweets and non-hate speech tweets. And then we can make some code after that will use those common words to see if the tweet is hate speech. So if you'll press play on this code right here, it'll be generating, or it'll just be counting, hold on, I'm scrolling. It'll be counting the number of positive and negative tweets. And if you press play right here, this will be making the word cloud, and right here too. So as you can see, with this word cloud, this is like the non-hate speech, like common words in non-hate speech tweets. So we see like these words, and these seem to be more positive words. While in hate speech tweets, these are the most common words. So based on that, we're going to be moving on and making a rule-based classifier. So does anyone know what a rule-based classifier is? Okay, so it's basically a classifier that is based on a set of user-defined rules. It's pretty similar to just using if statements. So these are the hate words that are most common in hate speech tweets. And so we're going to return 1 if these words are in any tweets. So basically, if one of these words is in the tweet, then we're going to say it's hate speech. Okay, so you can press play on this cell, and this is basically like training using the rule-based classifier. And then we're going to be seeing our predictions on the validation data when you press this cell. So we have 3 metrics. We're going to have accuracy, which is the % correctly labeled, precision, which is out of the how many you guess are positive or negative, how many of those are actually positive or negative, and recall, which is out of all the actual positive or negatives, how many of those did we label correctly? So does anyone know what the difference between precision and recall metrics are? Wait, what are type 1 and type 2 errors? Yeah, that's basically it, yeah. So, and yes, Stone, Trump was in that list. Okay, so I would press play on this cell. And then this is just going to see like what is the accuracy of the rule-based classifier. So as you can see, the rule-based accuracy was pretty good, but the precision and recall were really bad. So this is basically like from 0 to 1. So we have a class imbalance issue right here, which is like the distribution of examples across the classes are biased or skewed. So does anyone know why might it be better to use natural language processing over the rule-based classifier that we just used?
There's a lot of like different things that change based on context.
Yeah, definitely. Does anyone else have anything? Yeah, exactly. Okay, so I'll be passing this off to Vincent. He'll be going over the Nlp classifier. Make sure you turn this on. You just have to hold it longer.
Does it work?
Yeah.
Hello? Hello? All right, okay. Wow, this screen is very small. I'm going to try my best to look at this here. So I'm going to be covering the Nlp classifier. And so earlier, we just built a rule-based classifier. And what that basically is that it's using a bunch of like user-defined rules. So you say, if the sentence has this certain word in it, then maybe it's hate speech, or maybe it's a hate speech tweet. But now we're going to transition into an NLP technique called bag of words. And what this basically is, you can think of it as an actual bag of words. It's basically a vocabulary. That vocabulary is finite. And this vocabulary would have key value pairs. So the key would be a number, and the value would be a word. So you map numbers, words to numbers, basically. Here we go. I'm going to scroll down. So yeah, basically I'm saying language is pretty easy for us to understand, but for computers, it's just a bunch of numbers. So bag of words is basically another one of many techniques to convert a sentence to basically a list of numbers. So for example, here we have a vocabulary of some really weird words like Caleb bought some donuts, ate, right? And these correspond to a number, like a position. And we have two sentences here. Caleb bought some donuts, and Caleb ate some. And you can see that we just basically have a vector of numbers, and this vector would be as long as the vocabulary. And it would just basically count how many times each word showed up in that sentence. So for example, in the first sentence, Caleb only shows up once. So at position 0 of that vector, there's only a 1. And for the word ate in the first sentence, it does not show up at all. So you could see that at the very end of that vector, it's a 0. So I'm going to ask you guys a question. So what do you guys think are some potential issues with this NLP technique? And I'll show you that those two sentences again, are actually two new ones here. So notice how both of these sentences, they have the same vector, but the words are arranged differently. So what do you think affects the bag of words technique? Anyone? It's very simple. The words are arranged differently. This model doesn't take into context the actual order of the words or the context of the sentence in large. And that's what makes this model a little bit bad. This is something you might notice when you begin working with this. Yeah, so Caleb ate some has a wildly different meaning from some ate Caleb, yet a bag of words representation thinks they're the exact same thing. And that's kind of problematic, as you can kind of already tell. Yeah, so this model basically converts sentences to strings. And so we're not doing any prediction so far. And that's where logistic regression comes in. And that's a really basic machine learning technique. And we're not going to dive too deep into how that model works. We're just going to cover a high-level overview of what it does, like what it takes in and what it outputs. And then we're just going to hook this up to the bag of words. So here, recall our train validation split from earlier. Yeah, so we're taking that huge table of data, right? And we don't want to use that entire data set. We want a part of that data to actually we want to use a part of that data to actually check how well our model is doing, and the rest of the data can be used for training the model. So that's why we split up the data here. Right. Okay. So, and we have this is the sklearn API. They use something called account vectorizer. It's a really confusing name, but basically what it is a bag of words model, which I just showed earlier. I think I should be running these cells, right? Okay, let me see. Oh, shoot. Okay. Oh, wow, what the heck? Oh, this is the interactive notebook. Yeah, this is for you guys to fill out. It's really simple. If you guys need any help with it, definitely check out the sklearn documentation or API. Oh, I'm supposed to be doing it with you guys. Well, that's awkward. All right, okay. Wow. Shoot. Oh man. To be honest, I might have forgotten like how to write all of this code. Like it's been a little. Oh, okay, okay. Yeah. How am I supposed to hold this microphone and type at the same time? That's a good point. Yeah, I got headphones. You can use the mic. Here, could you type it? Could you type it? Anyway, I'll take this. Oh, shoot.
No, like the little stand or the little tripod.
It's the same thing. Hello?
Yeah.
Okay, can you go to the code? That's not the code. be doing the first to-do right here. So just erase this whole thing after the sign. Okay, so we're going to be using the count vectorizer function. So type in count vectorizer, make sure you're using parentheses, and then in parentheses we're going to be doing stop words. So stop underscore words equals, then in brackets, and in single quotes at user. Yeah. Okay, so that completes that line. And then the second to do, we're going to be, wait, actually I think that's all the to-dos for this one. So press play and see if it works. Great, okay. Is anyone's not working? Okay, great.
Okay, I'm back, guys. I'm back. So I'm going to be covering, so remember, we just made our bag of words model with the sklearn API. This is called a count vectorizer, and we have stop words. If you guys aren't sure what the stop words argument is, it's basically saying, okay, there are certain words in just like English, let's say, that aren't really that useful, and we can use them to say, okay, if this count vectorizer thing sees this word in the sentence, then it's just going to stop, right? So it's like a stop word. All right, so now we're going to move on to logistic regression, and this is a little complicated, not too much actually, but overall, at the high level, this is basically a simple ML model which takes in these data points, that table of tweets converted into numbers, and it's going to take those quantified tweets, and it's going to output a class 0 or 1. And of course, as you guys have seen, as you all have seen before, the 0 corresponds to, I believe, not hate speech, or was it not hate speech?
What? 1 is hate speech and 0 is not.
Yeah, so 0 would be not hate speech, and 1 would be hate speech. And this is like kind of like a visual representation of a model, right, of the logistic regression model. So if points were near the left end of this sign, like kind of like S curve, then it would be like 0. It'd be the class 0. And if it was towards the top right corner of this S curve, then it would be 1. Okay, so yeah, here we go. It says here again, it's a really simple model, and it just outputs 0s or 1. And this model can basically tell us, like, we can use it to predict whether a tweet is hate speech or not hate speech. So now here we're going to train our logistic regression model, and this is a to-do. We're going to have to build the model. We should type this.
You may do it.
Yeah.
Hello everyone, I'm back. We're going to be doing our logistic regression model. So let's erase this first to do. So just say BOML equals. So we're just going to be using the logistic regression function. So okay, and then just this whole line we can erase, or you can keep it there and just type afterwards. So bo underscore model dot fit, and then bo train vect, and then train underscore labels. Okay, and then we're going to be doing 2 more, so erase this to do, and then BOW underscore vectorizer dot transform. So it's going to take val tweets, and then one last to do. Okay, so that completes. Let's run it and see if it works. Okay, great. So this check mark here means it works. So did anyone's code not work right now? Okay. Okay, great. So let's move on to generating the accuracy, precision, and recall. So just like having those performance metrics. So for the first to do, we're going to say accuracy underscore score, and then val underscore labels, comma, bow underscore predictions. So that completes that line, and then we have one more to do here with the matrix. So confusion underscore matrix, and then val underscore labels, comma, bow predictions. Should be good. Okay, so press play and it should work. Is anyone's code not working? Okay, great. So Vincent's going to talk about using bag of words logistic regression versus rule-based classifier.
Right, so, okay, this works. Cool, awesome. So we just made two models, right? We made a rule-based classifier, which is really simple. If this word or this word is in the tweet, then we say, okay, it's hate speech. Otherwise, it's not. So that's the rule-based classifier. And our second one is the bag of words plus the logistic regression. And what that basically is, okay, we're going to take this sentence, we're going to count up how many times each word shows up in the sentence, and we're going to feed it into this black box logistic regression model, and it's going to spit out this number, either a 0 or 1, saying, okay, is this tweet hate speech or not? And now we have metrics for both of these models, and we're going to compare them and see how they fare against each other. Yeah, so yeah, in short, accuracy looks pretty much the same. Looks like the bag of words plus logistic regression does a little better overall in all accuracy, precision, and recall. Yeah. Okay, yeah, looks like this. We have one more part here called bag of words plus neural net, and it looks like we have. Should we cover this? Yeah, we're going to cover this. All right, so neural nets, we will explain this right down here, and we have a great visual for this. So sklearn actually has some class, like a function basically, for neural networks, and it's really simple. It's called Mlp Classifier. And so what is a neural net, right? So it's at its very core, it's like an ML model based somewhat on the human brain, and you could really like make these models really big by adding more and more neurons into it, kind of like a real human brain. And this is really popular. It's a popular architecture in deep learning. And this is how a neural network might look. So you can see that there are inputs, and there's like one neuron for the output. It only outputs 0 or 1. And there's a bunch of hidden layers inside. So these, you can think of those as kind of like just neurons in the brain. So neural networks are a little complicated. They're very customizable. I like to think of them as Lego blocks. So if you guys do want to learn more, there's a link right here where you could read up on the Mlp Classifier. So yeah, so we just have like a quick recap here saying, okay, we created the model, we're going to train the model, and then we're going to evaluate the model. And this process is very straightforward. It's used for basically all the models that we've made so far.
Okay, so for this section, I won't be doing it with you. We're going to give everyone around 5 to 10 minutes, and you can try it on your own, and you can ask questions. And then after that, we will be doing it with everyone. So, yep, everyone, you can try to make the model right now. And Twitch, if you have any questions, let me know.
Yo, how's it going? Oh, sorry, 1 second. Yes.
Should it be 1 or 2?
Oh, shoot, whoops.
Are we ready to see the answer? Okay, so I'll be doing this to-do with you. Let me turn off the mic. Okay, so the first thing we want to do is use the Mlp classifier that we talked about. So okay, so that's the first line of code. Now we're going to fit the model. Okay, so now we're going to apply the neural network model that we made to the val tweets bag of words and save our predictions. Okay, now we're going to be using accuracy score to calculate the accuracy. Okay, so for our next line of code, we're going to be using the confusion matrix, which computes the true positive, true negative, false positive, and false negative. So Chris, why is it centered? Why is it centered? I didn't know what. Come on. Yeah. Wait, right here? Yes, you are right. Thank you. Okay, so back to the confusion matrix. So we're going to be putting in vowel labels and again, neural network predictions. Okay, so the last thing we're going to be doing is using some math for precision and recall. So this will be for precision. Okay, so you can just copy this line we wrote, like the right-hand side. Copy that for now, and then do boat, neural net, recall equals, and then paste that, but we're going to be changing at the end. It should be 1, 0, not 0, 1.
But did you put bow and then matrix twice for the denominator, I guess?
For the denominator, yeah, it should be bow and a matrix for both.
Like 2 times, like bow and then matrix 1, 1 plus bow and then matrix 1, 1?
Yep. Wait, it shouldn't be 1, 1. It should be 0, 1 right here. Oh, wait, hold on. Give me a second. Yes, I don't know how that happened. Thank you so much. Okay, thank you for that. Okay, so you should press play and it should work. And we already have the print for you, so it should be printing the accuracy, precision, and recall. It does take a while to run the cell, so. Okay, so because we do have around 30,000 tweets, this neural network model is going to take a long time. So we're just going to move on while we're waiting for that. So comparing the bag of words with logistic regression and rule-based classifier, this is like the table comparing their performance metrics. So does anyone notice anything about these metrics, like what the difference would be using logistic regression versus a neural network? What would be the difference between using a logistic regression model and a neural network? Yeah, but like in terms of performance metrics, like with the table. Yeah, exactly. So precision is better for the logistic regression, but the recall for the neural network is better. So to conclude, bag of words is very simple, but it still outperformed our rule-based classifier in every metric. And when we're connecting our bag of words representation to different machine learning models, it produced different results. But there is an overall cap in the accuracy, in overall accuracy. And in our future workshops, you can learn more about different models we can connect for natural language processing, as well as we're going to be learning about transformers in our third workshop. So please stay tuned for that if you enjoyed this workshop, and you can ask any of the presenters today any questions that you have. So thank you so much for coming, and feel free to check in with the check-in code if you haven't already.